Matthews Gatos here. Welcome to Chapter 7, Lesson number 7, Division of Rational Expressions. Now, before I begin, glasses are strongly recommended for this lesson. Why, you might ask? Well, simply because glasses help with division. True story. Okay, let's get going with division. So remember the procedure for dividing a rational number? It's to multiply by the reciprocal of that rational number. So this is how I used to teach my junior high kids how to do it. We would keep Chewbacca fly. We would keep the first fraction the same, change the division to multiplication, and flip the second fraction, because that's what a reciprocal is. So we're going to keep Chewbacca fly for all our questions that we do. So let's try this one. 7 over 10 divided by 3 over 14. So keep Chewbacca fly. Keep the first fraction the same, so it stays a 7 out of 10. Change division to multiplication and flip the second fraction, 14 over 3. And now, in one step, it's just like a multiplication question. So I do 7 times 14, so that's 98. Over 10 times 3 is 30, and then I just look to see, can I put that into lowest terms? Use your math frac to help you, and 98 over 30 in lowest terms, 49 over 15. Okay, and my next one, 60 over 50 divided by 9 over 10. So again, I'm going to keep Chewbacca fly. Keep the first fraction the same, change division to multiplication, and then flip the second fraction, 10 over 9. So I do 60 times 10 is 600, and 50 times 9, 450. And then I can put that into my calculator, do a little math frac to see that in lowest terms, my answer is 4 over 3. Okay, so just really the only difference between last lesson and this one is that first little step. So let's talk about non-permissible values. So everything that we've been doing so far has a non-permissible value in the denominator. So for example, I have this rational expression a over b, and I'm going to divide it by c over d. Now a over b as a fraction has a non-permissible value. We can't divide by 0, and that non-permissible value is that b can't be 0. Well, look at the second fraction, c over d, also a rational function. That has a non-permissible value because I can't divide by 0, that d can't equal 0. Now, the first step in doing a division question is to change it to a multiplication question. So keep the first fraction the same, change it from division to multiplication, and flip the second fraction. And in doing so, we introduce a new denominator and therefore a new non-permissible value that c can't equal 0. So for division types, we have an additional restriction. So what my advice to you is list restrictions for everything except for a, which is the numerator of fraction 1. So that's what I'm going to do. I'm going to factor everything, state my restrictions right away, because as you get into the question, sometimes you get so focused on solving the question that you forget about your restrictions. So I do it in my very first step after I factor. So that's exactly what I'm going to do. Okay, so in this question here, I can't factor anything. So before I go any further, I state the restrictions for everything except for numerator of fraction number 1. So here I have 2x minus 5. So the opposite of a minus 5 is a positive 5. The opposite of multiply by 2 is divide by 2. So my restriction is x can't be 5/2. Over here, a binomial, the opposite of plus 1 is negative 1. And over here, a monomial, restrictions are always variable can't equal to 0. So my non-permissible values, putting them all together in order, negative 1, 0, and 5/2. That's all we're doing at this point, is just the non-permissible values. Okay, so for this one here, first thing I have to do, obviously, is factor. So I'm going to factor that, but notice I don't have a denominator on my second fraction, so I have nothing to flip. So the first thing I'm going to do is write it like that. So put it so it has a denominator, so now I can flip that second fraction. Okay, so let's state the non-permissible values. So non-permissible values only in the denominators and the numerator of the second fraction. So everything except for numerator of fraction 1. So 3a is a monomial. Restriction is variable can't be 0. A minus 2, nice binomial, so it's the opposite value. 1, no variable, no restriction, no chance of division by 0 there. A plus 3, the restriction is the opposite, which is negative 3. So let's just put all these guys together in numerical order. I'll say negative 3, 0, and 2 would be my restrictions. Okay, so let's actually go through and do a division question. So what we're going to do is we're going to factor, we're going to keep, change, flip, keep, Chewbacca, fly, state our restrictions, and then simplify. So let's try this. So in this question here, everything's been factored for us, which is great. So let's list our restrictions for everything except for numerator of fraction 1. So all of these guys need restrictions. So x cannot equal to 2, negative 3, 0, negative 1, and negative 3, which I already have. I can just put these into numeric order now. So from smallest to biggest, just to keep it nice and organized. Okay, and now I'm going to keep, Chewbacca, fly. Keep, change, flip. So keep my first fraction the same. Change the division to multiplication, and then flip my second fraction, only the second fraction. And now that I've done that, I'm at a multiplication question, so I multiply it like it's one big fraction, and I look for common terms to simplify. Sorry, common factors to simplify. X plus 1, x plus 1, x plus 3, x plus 3. It looks like that's it. So I'm left with x over 2 times x minus 2. And that would be my final answer with my restrictions. Again, you can always check on the calculator. You can check everything in this chapter on the calculator. So original question in Y1, what I think the answer is in Y2. The check always happens in the table, and you can see for all the permissible values, Y1 equals Y2, so I've done it correctly. Okay, let's try this one. This one looks a little bit messy, hey? Fraction over a fraction. So my first tip right away, just rewrite it using the division symbol. So it's a lot easier to do. So they're trying to make it look all complicated. Really, just use the division symbol, and then it's something nice and easy, okay? So before I can actually do this, I actually need to do some factoring. So 4x plus 12 has a GCF of 4. So dividing that out, I'm left with x plus 3. 3x plus 12 has a GCF of 3. Factoring that out, I'm left with x plus 4. Divided by 3x squared and 9x have a GCF of 3x. So divide both my terms by that GCF, and I get x plus 3. And then x plus 4 squared, I always like to write that out twice, just to help me when I am simplifying. So again, I state the restrictions for everything except numerator 1. So 3, no variable, no restriction. X plus 4, the restriction is the opposite. 3x, monomial, has a restriction of 0. X plus 3, opposite, has a restriction of negative 3. X plus 4, opposites, oh, I already have it. So let's just put this in numerical order. So negative 4, negative 3, and 0. So now that I've factored and I've stated my restrictions, I'm going to keep, Chewbacca, fly. Keep, change, and flip. So keep my first fraction the same. Change division to multiplication, and flip my second fraction. Okay, so now that I've done that, I'm going to look for common factors to cancel. So I have an x plus 3 with an x plus 3, an x plus 4 with an x plus 4, and that is it. So 4 and x plus 4 all over 3 times 3x is 9x, and that would be my final answer. Okay, let's try this. I want to write two rational expressions whose product means multiply, whose product is x plus 1 over 5x, so I want that to be the answer, with the restrictions of 0 and 3. So there are several answers you could have for this. I'm just going to do perhaps what I feel is the simplest way of doing it. So I want to end up with a 5x in the denominator and an x plus 1 in the numerator. So that means the original question must have that. So looking at my restrictions for my next hint. So 5x has a restriction of 0. Okay, that's accounted for. But I have this other restriction here of 3. Well, to have a restriction that x can't equal 3 using opposites, I know x minus 3 must be one of the factors that can't be 0. So because it is a restriction, I know it's one of the factors. But the answer doesn't have an x minus 3, and the reason is because it had to have been canceled before I got that answer. So this is in lowest terms. So if there's an x minus 3 in the denominator, there must be an x minus 3 in the numerator to simplify it to that point there. So this would be one possible example. Okay, and the next one, it says write the quotient. Now quotient is division. And that's a little bit harder. So actually what I am going to do is I am going to solve the multiplication part of it, and then I'm going to flip it for to go back to division. So I'm going to solve a multiplication question and then flip it back to be division. Okay, so I'm going to pretend that this is a product question. So I want to come up with a product of x plus 1 over 5x. So let's see, I need an x plus 1 in the numerator, and I need a 5x in the denominator, just like we did before. Okay, so that covers my restriction of 0. I have a restriction of 2, which means if x can't be 2, then x minus 2 must be a factor in the denominator, or perhaps in the numerator. And then I have another restriction of 3. So I have a restriction of x minus 2, or sorry, a factor of x minus 2, but notice I don't have an x minus 2 in this. That means they must have canceled. So I'm going to have a factor here and here, for example, because those would cancel. I'd end up with this as an answer. Then I also have a restriction that x can't equal to 3. Well, if x can't equal to 3, then x minus 3 can't equal 0 is one of the factors. Again, I don't have that in my final answer, so I must have an x minus 3 somewhere. So you could put that anywhere you want. So for example, I could say this one here is x minus 2, x minus 3. And then I can say this one's also x minus 2, x minus 3. So let's look right there. If I were to simplify this right now, say this was the question, I would cancel common factors, I'd end up with the correct answer, and I would have all of these restrictions. The reason the 3 is still going to be a restriction is because it's in the denominator, so is the 2. But I wasn't asked for a multiplication question, I was asked for a dividing question. So we're going to go opposite. We're still going to keep the first fraction the same. We're going to change it from multiplication to division, and we're going to flip it. So you can see I've color coordinated it for you here. So 5x comes up top, and x minus 2 times x minus 3 goes on the bottom. So this would be a division question with that answer. Again, there are several ways of doing this. This is just kind of the way that I see it. So to summarize division, you want to, again, factor numerator and denominator, list your non-permissible values for everything except for the numerator of fraction number 1. And then keep Chewbacca fly. Keep, change, flip. Look for factors that are common to the numerator and denominator and answer it by keeping it in factored form. Factored form is simplest form. It's a true fact, true statement that 4 out of 3 people struggle with division, but only a fraction of them will get that joke. You guys can work on practice. Practice makes perfect, of course. Assignment 1 to 10 in your workbook. I hope this video helped, and I look forward to seeing you for the next one.